This matters about how science has to do when, in terms of interventions, when you have to suggest interventions that have social impact. And I let them to introduce themselves because I am very lazy. That's the real reason. But the most important thing is not their social curriculum, which is very large and very important, but the ideas that have been cultivated for several years. And it is a great thing for us to be able to listen to them. So as Silvio said, we are going to have the two talks, one after the other. First Silvio, next Andrea, and I hope we can make some questions so they speak more. And
yeah. Whenever you want, okay. Can I start? Can you hear me?
Yes, go ahead, Silvio.
Can I go ahead?
Yes.
Okay, I will share my can you see my screen?
Yes, we can.
Can you see it?
Yes, your screen is on.
Can you see it? I can't hear you.
Okay.
Yeah, send it full screen, Silvio. Send it to
Yeah,
full
well,
screen.
I'm doing it full screen.
Okay.
Okay. Now,
Now it's okay.
Yep.
Okay, thank you. No, it's when we are in the distance, you need some kind of feedback that things are moving ahead. Okay, anyway, my name is Silvio Funtowicz. I was studied mathematics and philosophy of science in Buenos Aires. You know, I suppose there are some Argentinians there or listening. And then I left Argentina in 1979 and was for 10 years in the University of Leeds in the UK, where I worked with Jerry Rabbits. We developed our work on uncertainty and post-normal science. Then I worked as a scientific officer of the European Commission. I retired in 1911, and then I was for 10 years a professor at the University of Bergen in Norway. My work has been, and it is, on the subject of the relation between science and what we can call governance, okay? Now, I will start my presentation, and as I say, I will try to keep it in 30 minutes or something like that. So more or less, Andrea will have the same time, and then we have time for conversation, right? The title of my my presentation is "The Many Voices of Knowledge." I borrowed from an article in the Italian newspaper Corriere della Sera during the COVID pandemic. And there is an interview to an immunologist who was a member of the committee, scientific technical committee advising the Italian government about what to do about the pandemics. And what he says is that science has to apologize to the Italian people because it was unable to speak with one voice. Okay? Now, here I want you to think about the following. Can science speak with one voice? And second, should science speak with one voice? The fact is that I think one thing is clear, that this immunologist was right, and because science didn't speak with one voice. And this is, I think, the experience we have everywhere, and I suppose it's the same experience you had in Brazil. Now, in order to show just an alternative view, again, this is an interview to another expert, another member of a scientific committee advising the government, this time the UK government, about what to do in the case of pandemics. And what he says is, well, you can see it, but he says science doesn't tell you what to do, then can you ever follow the science? This follow the science was a kind of phrase that all governments and administrators used all around the world in order to justify and legitimize the measures they were taking about what to do about the pandemics. And then he says that how can you follow the science when apparently the same science producing totally different and opposing views and perspectives about among scientists about what should be done. Now, what I ask you to think and reflect is well, knowing the science does imply that you know what to do. Now, the point is that whenever this type of thing happen, when it is in the public arena, the fact that scientists express different views and even controversies are discussed in public, everybody is surprised. The public is surprised, the social media is surprised, politicians, administrators, even the scientists are surprised. Well, they are surprised, but we were not. Why? Because in the 80s, I was working with Jerry in a problem that had some similar features of the COVID, not all the same, but some of them. And this was the relation or the potential relation between emission from a nuclear power station in the north of England and the existence of clusters of child leukemia. And at that time, we had something quite similar to what we had these days around COVID, meaning epidemiologists, modelers, and local medical doctors disagree. And not only they disagree across areas of expertise, but also inside the same discipline. Epidemiologists disagree among themselves, modelers disagree among themselves, and doctors intervene with different views and perspectives based on their local knowledge. Okay, as the result of all this was that inconclusive, in the sense that a royal commission created at that time, what was called the Black Report, came out with inconclusive results. There was no way to ascertain to a certain level of reliability that there was a link between emissions and those emissions and the clusters of child leukemia. And then, and we are talking about, what, 30 years ago, everybody was surprised also. It's interesting how every time this happens, people are surprised, although it happened many times before. And to show you that, we were not surprised either, because in the 70s, Alwin Weinberg, who was a nuclear physicist working in Oak Ridge National Laboratories and the university that around it, published a paper that was entitled Science and Transscience. Now, the problem that Weinberg tried to solve was the relation, if you can ascertain to a certain degree of reliability from a scientific point of view of the relation between emissions of a nuclear power station and environmental and health effects. And in this case, you are not talking about an accident like 3 Mile Island or Fukushima. We are talking about a power station working normally, okay? And he comes to the conclusion in this article, which is, as you can say, is a citation classic, and although it was published in Minerva, which was a very important journal and still is, And so he comes to the conclusion that science is necessary, but not sufficient to solve this type of problem. Now, what is interesting is that, okay, you'll have my presentation, so you have the references and all the rest if you want to consult them after. Okay, what's interesting about this type of what is called citation classic is that it has other two interventions on the subject of transscience. The first is from Harvey Brooks, who then became the founder of the Kennedy School of Government in Harvard University. And what he says is that in his time in Europe, at the IASA, which is the International Institute of Applied Systems Analysis, he witnessed another type of transscience, the transscience that is the result of using complex simulation models. And here it says, well, since the time of Poincaré, we know that these are complex systems and therefore are trans-scientific. Now, the second perspective comes from William Ruckelshaus. And William Ruckelshaus was twice head of the U.S. Environmental Protection Agency. He was the first one. And he said he came to the job thinking that he had to intervene in problems that were mainly technical and scientific. And he discovered that there were really trans-scientific problems he had to deal at the Environmental Protection Agency. And he gave a definition of transscience, which is the one I want you to remember. And it is that a problem is trans-scientific when it can be expressed scientifically, but it cannot be solved scientifically. Now, that's the definition. Now, in my many years teaching and giving lectures, I say always that I could spend a whole semester discussing what does it mean that a problem can be expressed scientifically, and what does it mean that the problem can be solved scientifically, because these are very ambiguous statements. Okay, but still, I think you can get the drift of that. Now, from here, what I show is, this is from Nature, and you can see 1984, and it is precisely an article talking about the lack of analytical rigor and the problems of sensitivity and lack of robustness of those type of models, just for you to see one of the elements discussing precisely the type of trans-scientific issues I mentioned before. Now, the problem, as I see it, is here in this diagram, is we can call this the problem-solving strategy of the modern state. So you have a practical political problem. What you do is you translate it into techno-scientific problem, you solve the techno-scientific problem, and then you consider that the practical political problem has also been solved. This works quite well when problems are simple or even complicated, but the system is in trouble when we are talking about complexity, which I will talk about later. So what you have, why does it work? Because if the problem is simple, it is in a sense unambiguous. And the translation goes one-to-one with an unambiguous technical problem, right? So this is the way in which society has dealt, what I call the modern state, with the relation between science and society, and it is based on the duality between facts and values, where science discovers the facts, express them quantitatively, and then this can be taken in order to manage rationally. On the other hand, the political system will take care of the values. And when I say that this works quite well in these cases, is well, it enabled an incredible development of science and technology on one hand, and on the other hand, of the what we call institutions of governance, that of parliaments, etc. And it enabled, to the point that enabled to small European countries to become imperial and colonial powers. You have the example in Brazil with Portugal, no? So the system works very well, and it is based on some ideas that were present at the beginning of the modern state. And as I say, the duality between facts and value. Here is the hero in this whole operation. He's the one who invented modeling, really. And what Galileo Galilei, what he says is, well, he distinguishes between what he calls objective and subjective qualities. In English, we would say primary and secondary qualities. And the primary qualities are those important to do science. And the secondary qualities are those who we can ignore in order not to introduce elements of subjectivity, values, and uncertainty. Now, remember that for Galileo and people like Descartes and at the same time, more or less, that developed the scientific method, for them the universe or the book of the universe was written in mathematical terms. It was numbers and geometrical figures. So the whole purpose was of doing science was to obtain a quantitative statement that can be used unambiguously in order to decide what to do, legitimate action, and political decision making. Now, the way in which this is done is a form of reduction of complexity. So complexity is reduced by two operations that economists will call externalization. The first externalization is the context. So we think that the context does influence the system you are studying, which is quite stable and independent, isolated. The second and very important one, and this is the subject of Galileo's in this paragraph, is our bodies. Our bodies, our personas, because it's our perceptions, our senses that we have to abstract in order to get good science. And from this comes the model that I mentioned before. But as I said before, science changes with time as it responds to new challenges. So what happens is that with time, and coming to the 20th century, I mean, the master of indeterminacy, Werner Heisenberg, argues that what we observe is not nature itself, but nature exposed to other method of questioning. What it means, and he leaves open, and because, as I say, we are now introducing the idea of complexity, is that there is not only one method of questioning nature, and therefore our observations depend precisely of this, and they might be plural. They are not unique and single. Now, this later is more clearly expressed by biologist, a mathematical biologist, Robert Rosen, and describing as complexity as ambiguity. This is important because complexity in itself is ambiguous because there are different definitions of what it is. Here we follow some of these authors like Robert Ross and others, where complexity reflects the necessity for meditation of the restriction of a system. So in a sense, what we have is that complexity requires a plurality, irreducible plurality of perspectives that cannot be reduced one to the other. Once you discover that the type of problems are no longer understood as simple or complicated by complex, you lose this idea of uniqueness. So the practical problem is not unique, it's ambiguous. The translation is no longer one-to-one from a practical problem to a technical problem, and also the technical problem is no longer unique. And that has to do precisely with the collapse of the reductionist, the way in which complexity was reduced. Remember, on one hand, the context, and on the other hand, our bodies, our personas. If we see that context is important and relevant, and our bodies, our personas are also relevant and important, we can no longer reduce complexity in the Galilean or Cartesian way. Okay? Now, in order to give, yes, I'm doing well. In order to show how this original problem-solving strategy has been modified during these last years, I will give you a few examples from my own professional experience, and I think also Andrea's, because we have been doing most of these things together. So, and here I'm not talking about thermodynamics, okay? I'm talking about science, that it is done in order to provide an input for political action and policy decision making. I have to be clear, okay? So what it is called in I think in the course, Science for Governance, okay? So that can be science for regulation, science for the law, other type of ways in which science is involved in our governance systems. Okay, now I will go through all of this in a very fast, and then we can come back if you have questions. The first is I come back to the EPA and what I mentioned before, and this is an article again from Nature, 2008, and as I say, this is how do you solve that problem in the model of decision making, I mean, that I call the problem-solving strategy. Well, if you have to solve a political problem, practical problem, and you have to reduce it to a technical problem, and you have to solve the technical problem, what you do, you create an expert committee. You create a panel of experts to solve the problem. Now, in this case, it's about clean air. And you can see, well, some people may think that clean air is not such a complex problem, but actually it is. And what you have is that the expert committee, the EPA, quantitative must be characterized as having high uncertainties. And what it is interesting is that these expert committees have to deal with situations of high uncertainty. And the argument is that what to do in the face of uncertainty is a policy question, not a scientific question. And this is very interesting because one can argue that uncertainty is not a problem for science. Actually, it's a good thing for science. The fact that we have uncertainty is a challenge for us to do more science. It becomes a problem when high uncertainty is part of the input to the legitimation of political action. And the argument is, and this is important, is how much uncertainty a certain community, a certain organization, administration, society is able to tolerate in decision making. Okay, so this is the point here. For example, I give you an example also because, and I had a student, mine, she is a biologist expert on radiobiological hazards, and she represented Norway in an expert committee by the European Commission on GMOs, genetically modified organisms. So the expert committee meets in Brussels, and she said that she wants to ask two questions. The first question is, do we need it, GMOs? And the second question is, who benefits? The chair of the committee has said that these are not legitimate questions because they don't deal with risks. So all those questions for expert committees are not important. And as you can see, those questions relate, what I say, to the context and to the fact that our personas, our bodies, our senses, and our perspectives are very much involved. Now, the second happens very close to you. In Rio, I was in Rio in '92 when discussing what we call Agenda 21, local sustainability and so on. And the discussion was about the need for what it was called the precautionary principle. Now, it is called principle because it's principle 15 or something like that of the Rio meeting. And everybody knows that we were meeting there because there was a perception that things were not going well for the environmental health. And the question was, how can we respond with legitimacy to the question where there was scientific uncertainty? Right? Because in the model that we have is that you need scientific certainty in terms of simplicity or complication in order to legitimate action. Remember, it's always the same loop. Here, the question is how we intervene in anticipation to prevent further damage, okay, in presence of scientific uncertainty. But you can see the text. In the text, the word uncertainty is not mentioned, but it is what it says is lack of full scientific certainty. So the question for you is lack of full scientific certainty the same of scientific uncertainty? As you can see, the default is always certainty. It's always that science eventually will come up with the truth. And therefore, instead of adding a normative principle for action, political action, they say cost-effective. So they return the problem to proportionality. So this draft of the precautionary principle, I always define it as a politically correct cost-benefit analysis, okay? Now, the next one. Well, I don't know if you remember, here we have BSC, which was the mad cow disease, okay? Mad cow disease was a big scientific, economic, and institutional crisis in Europe. And I always I kept this picture of John Gammer giving to his daughter Cordelia Bergen, okay? And for those who remember Shakespeare and King Lear, well, she is Cordelia, okay? Now, and because of the mad cow, what the European Commission panel decided was to ban British beef. it was done in 96. But then the expert committee decided that we could go ahead with and import in Europe, in continental Europe, British beef and all the rest. Now, the French had an expert committee of their own, and their expert committee decided that it was not safe. Now, it looks like a scientific controversy when you see two expert committees coming to different conclusions. But when you look at it, it's precisely the point I was making, that what is safe? Safe is ambiguous, so therefore both committees interpreted the whole thing differently. And also the scientific problem, technical problem they solve is different. So it's not the result of a scientific controversy, but the result of precisely of the plurality and ambiguity of complexity. And here, as you see, John Gammer has been followed by the Japanese ministers eating food in Fukushima, right? So that is recent. They are still at the same tricks, Now, the next one is the range model, and it got to do with acidification. This is for an old paper we wrote in 98. And the fact that the problem acidification, emissions, industrial emissions, and the problem of forest and acid rain. Well, in a sense, you can say that this is a success story. And it's a success story because there was Europe used a model that called RAINS, which actually was not used because it was rigorous from a scientific point of view, or because everybody agreed on the science involved, but because all the members of the countries decided that it was a good point of negotiation. So the model was no longer a scientific input, but just a point from where they could negotiate and come to compromises. So here you have a new way of modifying the original problem-solving strategy of the modern state. The last one I want to mention is what it called the origins of popular epidemiology. And this is from a colleague of at the University of Bergen. And today, popular epidemiology is part of what we call this ongoing and a movement of citizen science. And the idea that community have to create their own knowledge, their own tools in order to solve their local problems, because in general, experts and administrators are not interested, okay? And here we have the lab canal, but something similar happened a few years ago in Flint with water and so on and so forth. So I recommend this article from our colleague Ragnar Fjell. Now, on the basis of all this, we realized that all these problems have certain features. And those features we called the mantra of what we call post-normal science. The fact that they are characteristics of a post-normal problem are facts are uncertain, values are in dispute, stakes are high, and decision urgent. When you have all these type of problems, I say the ideal of truth, of science as a truth maker procedure is untenable. So what we argue is that we changed the focus and instead concentrate on what we call quality in complex system, which is the relation between a knowledge input to a purpose that it has to be socially, politically negotiated and decided. And because this is done in the context of complexity, what you have is the knowledge input must be necessarily participatory, diverse, and pluralistic. Okay, I won't go on this, but the point is that what we see, I started with COVID, then I went through the history. And now we come to the challenges we have today. Climate change, ecosystem collapse, biodiversity loss, sustainability transition. All these share the characteristics of the post-normal science mantra, and therefore have to be dealt as complex, or as it is fashionable to say today, wicked problems. Okay? Not only we have to deal with them in this way, but also a context, as I say, is also very important. And what is the context? The context is the following, in which all this work is done, in which all these challenges must be faced. The first is that intolerable inequalities in the world, weak democratic institutions, authoritarian tendencies, and a magical idea about the role of science in society. Okay? And you can see that all the time. Now, we have, I think, discussed the fact that in the case of COVID, but not only, because in all the other cases I mentioned, you have the same situation. Science couldn't speak with one voice, because precisely it's no longer simple, but complex, and therefore ambiguous, and therefore you need, as Robert Rosen say, a plurality of irreducible perspectives in order to face those challenges. And but really, I think after COVID, we have learned that science doesn't speak with one voice. But we have still to learn that knowledge doesn't speak only the language of science. Okay? So in the Vienna, Otto Neurath proposed this idea of orchestration of disciplines, of scientific disciplines, in order to face the problems from the First to the Second World War, which are political, social problems, serious problems. I'm in favor of interdisciplinarity, but that's not enough. And the fact is that not enough is because we have to include other ways of knowledge that were very useful for humanity survival during its history. And just to show that this idea is growing and maturing, well, if you look at the International Panel for Biodiversity, it takes a quite different approach to the IPCC, and because it mentioned the need of plural values, plural perspective, plural systems of knowledge, and plural cosmologies. So my last sentence is, there is a lot to do. Thank you.
Okay, thank you very much, Silvio.
I can hear.
Okay, there was an applause here. We don't have an open microphone to the room, so you only hear my voice. Thank you, Silvia. We will come back, I hope, with questions. And we let now Andrea do his show.
Thank you very much. I will also try to share my screen. Here it is. Okay, let's see if I can also manage to send it to full screen. Okay, now you should be seeing it as a full
Yes,
screen.
we have full screen.
Can you confirm? Yes. Okay. So we can start. So in case you are interested in this talk, you can already find the PDF on my own website, which is very easy to find because it is the same as my name. You will see there are points of contact between what I say and what Silvio just said. This is a summary for you, but not for me to read now. I will be talking about mostly mathematical modeling, so I will be focusing a bit more on this aspect on which Silvio has already said a number of things. And I want to start with, if you want, with my total bewilderment of the fact that we live immersed in fantastic numbers. And my exhibit is this article from the New York Times, where they discussed the most important number you have heard of. We are given with 2 or 3 significant digit the cost of CO2 to be used in climatic negotiation, the so-called cost of carbon. And this cost of carbon has been calculated by all these distinguished gentlemen you see in the cover of this report. So what they do substantially is to average the US economy up to the year 2300. I believe this is pure madness, but this madness is apparently a very valuable currency because policies can be made out of it. So my reaction is we live immersed in fantastic numbers. Many years ago, I wrote a paper to demonstrate that if you explode the uncertainty of these integrated models of the environment and of the economy, you see that the uncertainty is so large that you cannot really say anything about that. And Silvio and Jerry did something very similar when they published many years ago the songbird paper. Now, a paper asking the value of a songbird, and they were reacting to a cost-benefit analysis done again by Nordhaus, one of the guy I take issue with in this paper, and they were calculating an addition of contribution, and the addition included a question mark. So I remember the nice irony made by Silvio and Jerry on how could you possibly make a sum when one of the other was a question mark. But I believe that among practitioners, we all know these things. Huh? So I came to the conclusion that mathematical modeling, more than other families of quantification, live in a state of exception. The state of exception, well, can be motivated in this way. The mathematical modeling has an incredible palette of methods, many more than statistics. They have an incredible epistemic authority, which descend directly from mathematics, and also mathematical modeling, not being a discipline, does not have agreed standard of quality. So everyone does mathematical modeling, and each discipline goes its own way in doing mathematical modeling, which is also something about which a lot has been written, no? So Silvio mentioned already, no? Mathematics is the language of God. Still today, when we want to make it to prove that mathematics is instead descent from human experience, as Lakoff and Nunez have done, is an unfinished project. So, well, for those who, like me, who are interested in sociology of quantification, sociology of quantification don't talk much about mathematical modeling because they are more on their terrain when they discuss statistical indicator or when they discuss algorithm. Today there is a lot about algorithms, but mathematical modeling is something where there is preciously little work. And this is a problem because we need this kind of gaze from sociology into the activity of science, as we know since the age of Latour. Here is an example of this work of sociology where they discuss how an assessment any kind of modeling work, assessment work, production of number needs to have a technical as well as a normative quality. And in this chapter I'm mentioning here, they make reference to new public management method, whereby indicators are used as to make, in a sense, policy-based evidence-based policy. This also descends from previous work done by the French School of Sociology of Quantification. Among goal, I want to mention Alain Desrosiers, who discuss how if you truly want to do evidence-based policy, you have to let this construction of object for study and analysis precede the stage where these objects are used. Otherwise, the interfight between different factions will transform evidence-based policy in policy-based evidence. So, which is what, again, Saleh mentioned here, no? Governance-driven quantification, which would be, in my language, policy-based evidence, is based on the pretended neutrality. And also, this is one of the causes of the present loss of democratic agency. This would be a long discussion. We cannot have it today. But I think, in a sense, Silvio alluded to it in one of his last slides. But on the other hand, we cannot do without numbers. We cannot do without model, because even contesting existing arrangement calls for different arrangement and different models. What requires muscle that at the same time are not easily available to the lay citizen. That's why model can play a role into the construction of some form of a democracy. This was the parallel between my language in terms of evidence-based policy and policy-based evidence, and the language of the sociologists of quantification, which talks about statistics proper and governance-driven quantification. What else to say on this? Of course, the issue of non-neutrality of method is again one of those things that practitioners know very well. I mentioned here just two, Gian Domenico Maione and Ulrich Beck, but which nevertheless is conveniently forgotten when models are deployed in the public arena for the making of policy. Here, if you wish, there is also an article I wrote with a number of friends and colleagues, including Silvio, Jerome van der Sloot, and Matthias Kaiser and others. And then there is, again, talking about sociology of quantification, this very important work, which discuss how the production of number is linked to the trust which the people bringing those numbers are endowed with. And this is where the study of COVID becomes crucial, because as we may, as I will say in a moment, people were not favorably impressed by how mathematical models were used in the context of the pandemic. Then again, why models live in a state of exception? As everyone knows, models cannot be falsified as a simple physical law. You cannot devise an experiment which falsify a model. As was noted, the relation between model and data has been even defined as incestuous. This is true of all large models. Now they come with a gigantic database which is used for their calibration. So really you wonder what kind of experiment would falsify those models. And today there is discussion of making digital twins of the planet, which drive me simply mad, but still they are they are in a quite advanced state of discussion. So they will reproduce the planet in silico, including its own humans and economy, taking information from mobile phones, voice, sensors, satellite, and what's not. So really, there is really little scope for comfort in all this. Models are also the success of models come from the fact that they are the most effective mediators between theory and reality. There is a few other ways to make sense of possible theories other than making models out of it. No. Jerry Raves writing in a paper which has been now republished in a book which just came out. Models can also be regarded as metaphors that I can understand us to see what is behind the model itself, to see what is our view of the world. How do we intend the direction of progress? No, I can read the model and tell you what kind of ideology is behind that. Then there are consequences descending from this state of exception. One is a gross asymmetry between developers and users, so which is even more serious than in the case of statistical information, because a statistical indicator at the end of the day can be relatively easily dissected, and less so a model made of several black boxes, which can only be falsified by someone who really understands what's going on in the model. And then there is the story of the ritual use. No model can be used ritually, and the most beautiful example I have here comes from Kenneth Arrow. When he was during the World War, he was making a prediction, and he was tasked with producing prediction of weather 1 month ahead. And so if you read the quote, he made the point that a statistician made it known to the general that those forecasts were impossible or useless. And the reply received by the generals was that the commanding general is well aware that forecasts are not good. However, he needs them for planning purposes. So you see this, well, in a sense, this also goes with Niklas Luhmann called it deparadoxification. No, politics use science to deparadoxify choices which are in a sense paradoxical because are given to the political negotiation, but they are presented as not a paradox thanks to science. And then the discussion you heard already from Silvio about following the science during COVID. On this following the science, with a group of friends and colleagues, we wrote a big manifesto to if you wish, note how this use of mathematical modeling during COVID was not really acceptable, no, was really fraught with more problem than solution. But at the same time, it must say that models have been very popular during the COVID controversy, so they gained a lot of power because people noted that the like of Boris Johnson and Donald Trump took decision based on the model. And in this case, the model was a model of Professor Ferguson from the Imperial College of London, which we criticized as not being the kind of model who could be used for this purpose. But then there was also a reaction. All those who didn't like the measure taken to contrast COVID start attacking mathematical modeling. But not only politicians like Rush Limbaugh, you see here, but also academical scholars like Tim Rhodes note mathematical models as public troubles in COVID-19 infection control. So the idea that errors were being made or that assumptions were being sold as reality and guide for action was quite well recognized by a number of experts. The manifesto in Nature made a number of recommendations, and I don't have time now to go through all of them, but we suggested to check the assumption of the model, don't make the model too big, mind the hubris, keep context. Mind the framing has to do with the context Silvio was referring to, especially in case like COVID, you cannot forget that. You had to identify winners and losers, for example, and this in the case of COVID was really not done. Since the very beginning, it was assumed that the worldview of those writing mathematical modeling was the worldview, and this was really not the case. Mind the consequences because modeling can backfire, and also accept the existence of ignorance, which was again one of the things which was forgotten during COVID. And if you want to know more, very recently with a group of dissenter, if I may say, we wrote that we are really not impressed by the way the scientific governance was deployed during the pandemic. We say that biomedical science was more than offset by its own failures, no? Okay, of course, not everyone agrees with our diagnosis. I wrote it with a medical doctor like Thunberg, a medical statistician like Ioannidis, which is quite well known, and with Daniel Sarevich, who is a political scientist. Then you heard already by trans science, no? So you know already everything about trans science because Silvio has mentioned it, and examples of trans science using produced with models that are not difficult to find. How many people will drive autonomous car in 2050 could be an example. How will the spread of malaria change if the global temperature increased by 1.5 degrees centigrade? And the last one I mentioned already, what will be the cost of CO2 average over the next 3 centuries, no? So the models in this way become like Borges' one-to-one map of the empire, described in De Rigor de la Ciencia, which this fantastic Argentinian writer wrote. But we will go back to Borges in a moment. The consequences again include the fact that models have the strongest grip on policy, no? They are quite influential. They can be quite influential. For example, the fact that now we proceed to implementing these digital twins, though the idea to many sound totally absurd, is a proof of how influential mathematical model can be. We know that in the field of experimental medical science, the percentage of non-reproducible results could be as high as 85%. This was measured in a number of studies by several scholars. Nobody can provide a similar figure for mathematical modeling. I would assume that it's even higher. Model can quickly adapt to the political context, unlike big experimental measuring and data gathering work. Mathematical modeling can navigate the political wind quite quickly, and can also act as a chameleon. So a model can one moment use as a tool for study, and the next moment it is used to make policy. And when you say, but hold on a second, this was a model only for study, they will say, oh, yes, this is just a model for study, but we happen to use that to give an idea of what might be happening. And we believe this should not be the case. I mean, a model is either developed for policy or for making some kind of what if kind of study, either an instrument for study or an instrument for policy. And then models, again, the consequence is that we see the model becoming larger and larger. Here I show something which is known as the conjecture of O'Neill, whereby when you increase the complexity of the model, initially you decrease the error because you gain descriptive capacity. But then the error increase again because this added description carries with itself more parameters, and the uncertainty of the parameter is eventually propagated in the output, increasing the uncertainty. So if you wish, there is an optimal level of complexity for complication, not even complexity in this case, complication for mathematical model, and this would be the minimum of the green curve. So how to solve? And now we move to the section on resolving this state of exception. Ioannidis has suggested pre-registration of modeling studies. You probably heard about pre-registration. Normally it is suggested for medical studies or studies where you have the execution of a number of physical experiments on either people or animals or laboratories. And this is done in order to avoid formulating the hypothesis after the results are known, which is a well-known statistical malpractice. If I pre-register what I'm trying to demonstrate, I will not be able then to change the question just because some of the question had an answer in the data which were produced. And then there is the study of the forking path and fishing expedition, which I want to go back to. And this story again lead us to go take us back to Jorge Luis Borges, to this short story, El Jardín de Senderos que se bifurcan, where the novel is about the novel is a novel about the novel, as usual in the style of Borges. And this novel is a very strange book written by a Chinese author, where you don't understand what's going on because characters appear and disappear. They seem to be dead, but then they appear again. And the mystery of this book is that the author takes different path in each chapter. So, like if he were crossing a garden, but every time that there is a bifurcation in the garden, he takes both left and right, and so the chapter accumulate without a clear path going through the. It's not a clear path. There are many paths through the garden of the forking path, no? And this is studied by statisticians because statisticians have said, well, what happened with the statistical work is that very often statisticians navigate this garden and make choice. They go left on right, and even without any bad intention, they ended up fishing for a meaningful result, no? And doing what I mentioned before, no? The formulating hypotheses after the results are known, that this is the case, and this is important, this is my, if you wish, this is my smoking gun. This was actually measured, no, very just a few years ago, 2 years ago, in 2022, last year, a big experiment was done where the same data were given to 75 different teams. They had to draw a conclusion from the same set of data, and the data were concerning whether there was bias in the referees of soccer games. So one was expecting some kind of positive inference, so that the referee were indeed biased toward the minority players, but the result instead are all over the place, from negative to positive to I would say even a large majority of results showing no or little effect. So this is really a smoking gun of the Garden of the Forking Path at place. And a few days ago, a similar article came out in Nature, where instead of statistical models, the experiment were actually experiment in the laboratory. I don't have time to go into that now, but there is a fundamental this is a fundamental property of science, that it's there is so much ambiguity and late latitude of choice in the construction of experiment, either in silico or in vitro or in living organisms, that you may find this kind of effect, no? So the result varied from large negative to large positive effect. So sensitivity analysis, which is what I have done for a living for a long time, and sensitivity auditing can assist sociology of quantification in activity of the construction and reconstruction of mathematical model. On the example of the French stat activist, let me say a few words now about stat activism, no? Which can be used to, in a sense, to do something which we call modeling of the modeling process. So again, it would be, let's navigate the garden of the forking path yourself, because you don't have 75 teams willing to repeat your result. So it's better if you do it yourself to start with. And you can, if you do this, you can check simultaneously the technical and normative quality of your work. For example, here I have an example of how you can use sensitivity analysis to check that an algorithm does not discover, does not make visible attributes which should not be made visible. And you see a table here. You can also use this to avoid quantifying at all cost which is also an admonishment which often you hear from sociology of quantification. I mentioned here another work of Theodore Porter. So, solution to resolve the state of exception, again, sensitivity auditing, but I wanted now to move to this idea of the normative quality and the technical quality, which is again in the book I haven't discussed, but which is it just came out last August on the politics of modeling. Another solution to resolve the state of exception is to spend more energy in interpretation rather than in construction, rather in complexity, no? Of course, not all models can be simple. A finite element model of a human heart cannot be simple. It will be very large and will need a supercomputer to run. But I remember that in the 70s, a very useful and constructive discussion was held on the I equal PAT model, whereby the impact of human on the environment is driven by population times affluent time technology. So this was a very stupid model made of a very simple equation, but we still today discuss this model and its implication. You have the reference now to the Ehrlich and Aldrin where this discussion took place. So again, I had promised to say a few words about stat activism, which is something modeling might prove to emulate. Stat activism suggests to fight a number with a number in policy, in field of which are policy relevant. For example, we have example in measurement of poverty, measure of consumer price. One would like to see if models are capable of emulating what is done. This is not easy, to be frank. There are reasons why stat activists were successful, and this would be more hard for mathematical modeling. But if you want, we can discuss it later. So again, with stat activism, you could deconstruct existing metrics, including the use of irony, a bit like I mentioned before in relation to the Songbird paper. And here you have Pierre Bourdieu, which was one of the most well-known sociologists of quantification in the French school. You can do gaming metrics like a statistical judo or using the Goddard law to your advantage. Which means that you play the system. Now, if you are measured by a system, what you do, you change your behavior so that your behavior looks more beautiful according to the measure which is being used to measure you. And this is what done by policemen in New York. There is one of the articles in this book. Discover new categories. No, in one of the chapter in this book, discover the social classes, which is the so-called creative class, is in describe how this creative class is in fact a class of precarious intellectual. Then can discover suicide at France Telecom when France Telecom was privatized. Again, these were losers under the radar. No, nobody noticed those losers until the French statistician and the stat activist took note. And then there is again this new measure of poverty inequality. So stat activists don't want to suggest that we get rid of quantification, but only that we replace one number with a better number. So I mentioned already, but now I should maybe the reciprocal domestication between model and society. We have discussed this this point. And the fact the mathematics of uncertainty, this is something which Silvio and Jerry have also written in their book in 1990 as one of the things which was absolutely important. Now that the uncertainty, the discussion where you have to use risk or you can use other question other than risk. And again, the non-neutrality of model, which I mentioned already. So conclusion, and so I also stay within my 35 minutes. Does model need skepticism? Well, need rescuing, sorry. I think that models are today faced with a challenge, and the challenge is that people lose faith in mathematical modeling. I mentioned the skepticism following the use of models during COVID, and also the fact that modelers are not really forthcoming. You know, they resist this kind of argument, the argument I presented in the course of this presentation. Modelers enjoy when models can be used for displacement. Now, what Rainer called displacement, the changing of the reality with the model. So instead of acting on the reality, we act on a mathematical modeling. And one problem whereby the situation is more difficult in modeling than it is in statistics is that as noted by J.D. Raves in his work in 1971 on science as a social activity, if you want to reform a field which is sick, you need really integrity and commitment by members of the same community. No, I have the impression, I hope I'm not too pessimistic, that while statistics has been seen to possess this kind of energy or disciplinary arrangement to intervene in the discussion, maybe not all statisticians, but quite a significant numbers. I'm not sure the same can be seen in the case of mathematical modeling. Thank you. This is where you find the references. Okay. And there is some more reading and watching for you, which you find in the slide. And I can stop share. Voila.
Okay. Thank you very much, Andrea. Very nice talk. We have now opened the room for questions. ¿No se escucha? No? Oh, I am not for television. We have 2 microphones. How many hands raised? Okay, first question.
Okay, hello. Can you hear me? Creo que no, parece que no. Can you hear me? Parece que no. No sé. Hello? Can you hear me now? Hello, hello, hello.
Alô, som.
¿Está funcionando?
Hello? Hello? Can you hear me?
Yes.
Yes? Okay, perfect. At one point, you named a principle that was
Can
like,
you introduce yourself?
Oh, yeah, sorry. I am Adrian Lopez. I am a engineering student. I really like the concept you presented, that one can't always like I am just going to say, like, trust a model 100% if there is some uncertainty. You have to look at what you are trying to do with the model, and then you can decide what measures are you going to take to solve a problem. I really like the concept, but at one point you presented a principle that was like a model with high uncertainty cannot justify stopping a cost-effective measure, something like that. Yeah?
You're asking Silvio, I guess.
No, you.
It's asking me. No, it depends. It depends again. I don't know if I understand what your question, but of course, the fact that a model is uncertain is not necessarily prove that it is useless, no? You have several cases. In one case, you can have that the model can be proven to be so uncertain that it cannot be of use for that particular question. And it is already a good result, because at least we know that we don't dispose of an instrument to solve the issue. On the other hand, the model, by mapping the uncertainty, can make us aware of what is missing, no? So it can guide our action. So I would consider that uncertainty can be precious in a sense, can be valuable, and only by neglecting it, we do poor science. I don't know if this answered your question.
Yeah, but I have another question that is, who should decide what amount of uncertainty isn't forbids one from following a model? I don't know if I am posing my question correctly, but who should decide the amount of uncertainty that is needed to, like, how can I say? Huh?
Yeah, understand. No. Clearly, well, as Silvio said, this is a political question. So my job, or your job, I guess you will be someone, developing this analysis, no? Your job is to map the uncertainty, and then what decision to take on the basis of this uncertainty as it is displayed, when you look at it in the face, no, this is a political question. What we say should not be happening is that the assessment is presenting some uncertainty, the politician interpret this, there is certainty, hence I can decide, and I go ahead. Does this answer your question? Sorry, Silvio, go ahead.
If I might add, remember I mentioned this uncertainty tolerance, and different communities, different institutions, different structures of governance have a different way of tolerating uncertainty. I remember quite well in the case I mentioned this British judge who said, I might be wrong, but never uncertain, because that's the way the common law works. So there is no uncertainty. There might be error, which are two different aspects. The other element I said is, well, you know that there is uncertainty every day. You do a cost-benefit analysis for, let's say, a traffic or road regulations, or even how many mammographies are you going to do in a year. But you see, so the society tolerates so many dead and injured in road accidents a year. But if a bus with 25 children has an accident and many of them die, well, there is no tolerance for that. So you see, each case has to be analyzed separately, because it has to do, as I say, with the complexity that includes ourselves, our values, our perceptions, and also the context.
Okay, thank you. That answers my question. Thank you very much.
Another question?
Hi, my name is Paula. Can you hear me?
Yes.
Yeah.
Okay. My question is for Silvio.
Can you give me your name, please?
My name is Paula. Paula.
Good.
In the end of your presentation, you talk about the interdisciplinarity, and this is not sufficient, and we have to pursue more knowledge. And I want to know what kind of knowledge and the sources of this knowledge.
Okay, that's a good question. I never have time to talk about that. But you see, I'll give you just an example, but we can give more if you want. The example is, you know how the problem of longitude. Longitude was the establishment of a measure called longitude was absolutely fundamental for the development of commerce and the expansion of European powers. So the British Parliament put a reward, a big reward in money for someone who will come with a solution to that problem. Of course, it was not a problem of, it was not called then longitude, but it was a problem of establishment of, navigation ideas and rules. Well, Newton participated in this trying to solve the problem, other members of the Royal Society. I think even Leibniz participated in that. They couldn't find a solution because they were all thinking about science and how this will derive from the movement of the star. The problem was solved by a clockmaker, a craftsman called Harrison in Yorkshire, in the north of England. He developed what it is called the Harrison clock. And then longitude was established. The fact is that if you go to Greenwich, where longitude 0 is there, you will see still the clock by Harrison still working. And the British Parliament didn't want to give him the money, the award, because he was not a scientist, but just a craftsman, you see? So this is how we eliminate this knowledge. This is uncomfortable knowledge. Even if you go back to the dome in Florence and the creation of the dome, that was done by someone solving the problem of the equation, but at the same time of creating the tools that were necessary. So what you have is a lot of practical knowledge that has been used but not acknowledged, have important ideas about and influences in the way we face new challenges. Even during the COVID pandemic, you remember, everybody might remember that the main advice was wash your hands. Well, wash your hands. The idea of washing your hands comes from a doctor called Semmelweis, who realized that nurses and doctors were working with bodies in the morgue, and then were working with in the places where women were expecting to deliver children, and of course they passed infections. But when Semmelweis said that you need to wash your hands, that was not what medical science of the time said, and he was ridiculed and ended really badly. It took quite a while, and ideas about science, medical science, changed until we realized that Semmelweis was right, you see? So we have to think about all different types of knowledge coming from practical knowledge, from experience, etc. Tacit knowledge of different types of expertise that are important if we are going to face the problems. You know, the tragedy is that now, as I say, the International Panel for Biodiversity is calling another, we need to preserve indigenous knowledge when we almost destroy it all.
If I can share a second the screen, I really would like to share with you this fantastic book. It was suggested to me by Jerry. And this is really, can you see this? Yeah, I guess. And this book is really fantastic because it adds to the example you heard from Silvio of longitude and the Semmelweis story of hand washing of medical doctor, which wouldn't listen to Semmelweis. And it is a book whereby science is done by the craft more than it is done by academia. So it's really an interesting book to read. I use it when I teach scientific integrity. You know, in order to decide what is scientific integrity, you have to decide what is science. But perhaps the idea we were given about science as very much biased by academical science. And there are other ways of saying the story of science, as you can see from this book, which I suggest.
It's an important question that you put, and this is why I ended with that. You see, interdisciplinary is good, but nobody knows how to do it because the structure of universities and disciplinary science doesn't allow for it.
And journals,
so journals
don't allow it. They don't take you. If you write a interdisciplinary paper, you will never publish it.
So what we are arguing is from transdisciplinary, which is beyond disciplinary science. And I will add something more. The idea that Andrea was important, that book and all the examples, because it shows that our society, our method of problem solving has to do with science knowing that and not knowing how, and forgetting that science is also a craft. And the example, fantastic when it starts in Europe, this distinction, and when it is considered knowing that privileged type of knowledge come from the type, as I mentioned, of Brunelleschi. I didn't mention his name. Brunelleschi and the solution of the equations for the Dome of Florence. But what people don't remember is that he built the tools, but at the same time the craftsmen are keeping the dome in place because if not falls, because equations are not real.
And he patented it. The Brunelleschi was the first man ever to patent an equation substantially. No, it was the first example of copyright for a product of the intellectual mind. It's an extraordinary story, no? The story of if you want, you can read it on Feyerabend. I believe it is in the Discovery of Abundance.
In the Discovery of Abundance.
Yeah.
Thank you.
Sorry, we get excited.
That's very nice. More questions?
Hi, can you hear me? No, I think that this is the one. Hi, my name is Marcelo. Thank you for your talk. I wanted to ask you a question about transscience. When you face a transscientific situation, do you think that this is something that is inherent to the problem, or it's just a manifestation of our incapacity to ask the right question or to produce the right model?
Is it for me or for Silvio?
Go ahead, Andrea, go ahead.
No, I believe that, Galileo, okay? Galileo, we hear that Galileo was a great scientist and was a victim of the persecution of the church. There is this story of Bertolt Brecht, popularized it as a victim of the bad church persecuting him. But Galileo is a good example of an entrepreneur. What he does is to sell the telescope to the Duke of Mantua for military application. Where do I want to get? I want to get that the scientists have always been, and today are even more, entrepreneurs. So they sell their product, and they push for selling their product very vigorously. You know, you can see how they compete for the top of the policy agenda, you know, on COVID, climate change, transition, biodiversity, and what's not, no? Various disciplines compete for, because competing for the top of the policy agenda is also competing for grants. So I would say that the point is that society should become more circumspect, no, in accepting all this offering, because some of this offering is really una estafa in a sense. No, I wouldn't say a fraud, but it's really a product which is transscientific.
If I may, this also is an important question, but it will take more time than we have, because it's not that the world was simple and now has become complex, or we could solve it before and now it has become transscientific. You know, I am in favor of the ideas like Heisenberg and all the rest. It's the way you interrogate the system and how that changed over time, you know. So the idea that the universe is complex and before it was mechanic, I mean, it's nonsense. The universe is the universe. It's us which are asking questions in different ways according to different social, cultural, ideological context.
Okay, thank you.
Unless you're a candid realist.
Oh, thank you, Andrea and Silvio. My name is Christian. And I think, but this is just what I understand, that the model works very well for the thing that was designed. So, and the model always gives you an answer. The point is the question. If you say, if the question is right to the model, to answer the question. I don't know if you understand my point.
Well, yes, because you know, Andrea could talk more. As you know, in statistics, there is the errors of type 1 and errors type 2. There is also errors of type 3, which is answering the wrong question. So most of the time, models are answering the wrong question. So, but who decides what is the right question? But that was implied in my in saying how has evolved the original way of problem solving of the model state. That substantially, when the whole idea becomes complexified because you understand that there is a plurality of perspectives on what is the problem, what must be done, how you can translate into a technical scientific problem, etc., and the technical scientific is itself complex, then who decides is the question. And that is not a scientific issue. I mean, many times scientists have tried to say that because they are, as Andrea mentioned, objective, neutral, there is something special and they are morally superior. Well, we know that it's not true. Oppenheimer, for example, perhaps you've seen the film and all the rest. So it's a question to when it comes to this situation, we have to devolve the problem to the democratic system. And of course, there is a big discussion about what democracy means today.
Thank you, thank you.
Questions?
Hello, my name is Rocio. I'll try to do it in English. And I am a biologist. I'm not working now in biology, but I am a biologist and I work in the environmental agency in Paraguay for some time. So you say, the question was if science should speak only in one voice, right? And then that for some political decisions, you could take a panel of experts and they found a solution. But what I have seen when I was working is that they are not really even speaking their voice because you know that politicians are not going to accept possibly the solution that scientists, environmental science, biology scientists find. So they try to compromise. I don't know if that is the word. They try to compromise. So for example, you have a forest and you have the pressure to manage that forest, but you know that you are losing diversity very much. And you are even with exotic plants, even worse. But, well, it's that. I think that sometimes we are not even giving our real voice. to the world.
Yes, I understand perfectly well what you're saying, but you see, with Andrea, we worked at also for the European Commission that was supposed to provide science for a policy of the European Union. And sometimes scientists working in that context forget that they are working in a political institution. So you start by compromising just because you are working for a political. It's not bad. Don't misunderstand me. That's not bad. But you have to see that there are different type of contexts in which scientists develop their work. You can work for private interest. You work for the administration. You work for different contexts, and that will provide the framework, the context in which you will develop your scientific work, and even it will tell you the boundaries of what you can do and what you can't do. Sometimes scientists rebel. On this problem. You know, we have the story of the Dutch Environmental Protection Agency, where one statistician denounced and reported the agency because he said they were lying and giving bad numbers, and the models were bad. It was a big discussion, and even in the parliament with the press and all the rest. And at the end, they came to some kind of compromise about how to handle. There is a book by Laura Salter called Mandated Science, which explains what is the predicament of a technician or scientist working for essentially a political institution. What can you do and what you can't do, and what happens when you become a whistleblower, no?
My name, Andrea, your microphone is off. So
Yes. I wanted to say that for a year or so, I've been working on with some friends on a colleague of discussing regulatory capture. I wrote a paper on that, which was very difficult to publish, by the way, for reason you can imagine. And the point is that scientists are also sitting in the laboratories of great corporations, when not only this is mandated science, but they also work for producing product which then eventually someone else finds to be dangerous or toxic and so on and so forth. So science is everywhere. It's not only in the regulator, but it's also in among the industrial, what we call the invested interest. And the point is that what our article was about is that often science is used as an instrument of regulatory capture, no? So those people who want to capture a regulator try to do this by showing that they have the best science and the best scientists and that they are in the right. And then they are, of course, then they say that they are neutral and so on and so forth. This is also another aspect of this discussion.
My name is Alan. Instead of a question, I have several statements to check if I am correct or not, if you are agree with me. I think the thing is about the models is like we tend to forget that the models are a simplified version of the reality that we try to describe in a descriptive manner or in a quantitative manner or in a predictive manner, but because of their limitations, the model has a scope of application. So the thing about when we apply it, or if we can apply it in some examples or in some political issue, maybe it's the model itself that has to make the decision in order to apply it or not, because the model will say the uncertainties tends to be in this range of action. So we are outside of that. The model cannot say anything about it. So that's my statement. See if you are agree with me or not.
Well, so and so, in the sense you anthropomorphize, you have an anthropomorphic view of mathematical model. Mathematical models don't have agency. They are used by human beings, no? And human beings have their motivation. So it's not the mathematical model that speaks by itself. You know, the mathematical model is in the hands of someone using it. So again, as Silvio would say, context. Now, who is using this mathematical model? Who has paid for its development? What is the agenda of those behind the use of this mathematical model? So again, this brings the discussion away from the mathematical model, more toward those who have to use them.
Thanks.
If I may only add that one has to be very careful when we talk about reality, really. And I don't think there is a great agreement about what reality is.
Hi, my name is Vinicius. I'm a medical physics student. Thank you very much for your lecture. And what I understood here is that from the first question, it is our duty to map the uncertainty of a model, while it is the politician's duty to decide either to use that model or not, right? But of course, it's not expected from the politicians to understand the working and the building of a mathematical model. So my question to you is, what do you think is a good way to make the conversation between science and public politics?
Well, this is a $1 million question. What can I say? I mean, you know, there is, interestingly, no, there is a kind of cottage industry of people studying scientific governance, input science advice to policy, academy groups. They have huge conferences about that, which is the right way for science to feed into policy. And then something happened. Everyone is taken, you know, with his pants down, you know, and one doesn't know what to do. And the first casualty of the war is a plane, no? So we seem to have, in principle, an arrangement whereby everything is taken care of. We have committee, we have, let me make an example. What happened with the lab leak hypothesis? No, I don't know whether COVID escaped from a laboratory or not, or came from nature. At this point, I really don't care. What I do care is the real mess which the science institution have done of evidence and of our chances of ever getting to know what happened. No, so you ask me which is the right way. Well, I don't know, but I can tell you that this is not the right way. What we are doing now doesn't seem to be the right way, and people are correct and are right in being angry, in being disappointed, in being skeptical, and they are also right in becoming more circumspect, as I was saying, toward the way science is used to support policy.
If I may add, there's an interesting aspect in your question, and I like to think as science and we call policy, let me use that on government, just as labels, no? They co-evolve. I mentioned they started with the origins of the modern state in Europe after the treaties of Westphalia. So I always laugh because it's easy to say politicians, the scientists, they don't give me useful information. The scientists, the politicians don't listen what I'm saying. They don't understand the problem and so on. These two institutions and these relations co-evolved in the way we develop our institutions. They co-evolved in the law, they co-evolved in the politics, they co-evolved in the parliaments, they co-evolved in the development, and it became stronger, that co-evolution, after the Second World War, with the report by Vannevar Bush about science, the never-ending, what is, frontier or whatever, which science becomes the driving force of the economy, of growth and employment. And now, as with economy, growth is a virus, with science also growth is a virus. Now we are seeing the pathologies that growth has produced in the economy and in science.
Thank you.
Hi, my name is Nicholas, and I want to ask a kind of out-of-the-box question, I guess. I wanted to know from both of you if you've ever seen or heard about some scenarios in which there were scientific and, let's say, extra-scientific knowledge working in unison. So, say, scientific and like indigenous peoples and so on, working in a healthy way in a decision-making scenario, maybe. Just wanted to hear from both of you.
Yes, Silvio, do you want to go first?
No, go.
Well, there are several, many examples. I mean, many. Always not enough. Always too few. Always few precious example of co-production of knowledge. One was already shown by Silvio in the paper on the Love Canal story. When the lay people were right and the scientists were wrong. Which was again, as Silvio mentioned, replicated in the Flint story more recently. Local people know very well the quality of their water. Local people know very well whether the basement is becoming poisonous. Local people know very well, in another famous case of flooding risk in northern England, why is that the land is flooded every rain season? Because they have knowledge which is most often not accessible even to the agencies which are deputed to tackle the issue. The point is making this knowledge available. So, and this is probably again a political problem. Who decides that the local people have a right to be consulted? When COVID exploded, it was assumed that white collars knew the solution. But where the blue collars, asked about what they thought was the right solution, this is clear. This clearly was not the case. So probably if solution of if what to do during the pandemic had been negotiated between different social classes with different demands and different needs, also among different ages group, because what was done to children is really awful in terms of lost learning and psychological problem and what's not. It would have been extremely useful, but simply wasn't done. So democracy failed there, in a sense.
From a practical point of view, those who, Andrea knows that in the European Commission that because of, we won't go in details, but it came a point where we started to accept that people, fishermen, have important knowledge that was relevant in establishing fisheries policies. The same with farmers. We recognize the knowledge that farmers have and that were incorporated. And that has been slowly expanding. Now there is the European Commission in research. They fund many different types of citizen science, starting with popular epidemiology. I mean, there are projects in which epidemiologists and other scientists work with local people in framing, deciding, and of course, citizen science is a big umbrella name which includes a different type of intervention. Some of them are subsidiary, no? People only collect data or are used, no, as in case of health metrics, no, personal metrics. But in other cases, they shape the whole projects. Like in medicine, we know that patients, in case of AIDS or HIV and other things, have been very instrumental in shaping the type of research and introducing their own knowledge. And in that sense, there are many, many examples, which is something that it is expanding because people are not ready to wait. And we have Brazil, but also in all Latin America, we have communities that they are developing their own knowledge in order to protect their communities, their environment, and their health, and their children's health against all type of predatory entrepreneurs that many of them are scientists, you see.
I'm a bit more pessimistic than Silvio, but I believe those predatory can have easily can have very often the upper hand, but this is again a matter of perspective. Again, in the context of the regulatory capture I was alluding before, no? So that you have, yes, a citizen science, but then you discover that corporations use astroturfing, no? Initiatives which appear to be like citizen science, but they are not. They are simply produced. Okay, I don't want to discourage you too much. Maybe I should stop that. But it's a very conflicted landscape.
It's a question of political power as well, right? Like who has most power and imposes solutions upon others and so on, right? Always boils to that.
Just to mention, because you are in Sao Paulo, that there is work by researchers at the university there that work on post-normal science as an extension of the ideas of Paulo Freire. So these are very interesting developments, and we are very proud of being, being seen as part of Paulo Freire's tradition.
That's interesting. Thank you.
Do we have more questions?
Well, if there are no questions, I shall want to...
This is Hernan again.
Herman.
The question for Silvio. Do you foresee that in this coevolution of society and science, which is, after all, a part of society, a new science is coming? I am meaning the young people is really concerned about the future of the planet. And this is a strong driving force. And if science is a living thing, I would expect to adapt to the society, to adapt to this driving force. But then I would like to know what you think.
I think that, I'm an optimist. You see, I'm an optimist because things cannot continue as they are. In my view, some arrangements that the regime that we have, that comes, as I say, from very old, the beginning of the national modern state, is collapsing. And because this is what called today the polycrisis. What we see is that the whole political system is collapsing, and whole ideas, as I say, of democracy collapsing, but also the scientific authority is collapsing also. And so I think that we should be humble, forget the hubris, and change. And this is, I'm using the opportunity to talk to the young researchers that are caught in an almost impossible situation. And this is why in Europe, in other places, they are leaving the universities in drones. I mean, because they don't have a future and they don't like what they are asked to do. But what I'm trying to say is that if we think about the role of science, not as one of control and prediction, but one of responsible anticipation, then there is everything to be done. So we have to think about small and projects and experiments based on the territory and the real problems. And as they say in Italian, if we have many and if they are roses, they will flower, okay? And we'll have to recognize that we are going to make mistakes, that we enter a stage of experimentation rather than one of control and prediction and a blueprint of the future. You started by saying they are concerned about the future. It's good that they are concerned about the future. Unfortunately, they should be more concerned about the present, because the future is a product of what we do in the present. And when we talked about the future, we forget that we have to do things now to change the situation as it is. So I am a nowist, meaning do things now, don't think a lot about the future, because the future is to be created, and this is the role of the young generation. Not to produce more knowledge about things we know more than enough, but about things, how can we do, how can we live together in this planet without thinking some scientific solutions like immortality and going to explore the stars, which seem to be the more prestigious type of techno-scientific activities today.
Okay. If there are no more questions, we want to give a very great thanks to Silvio and Andrea. It has been a very nice talk, and it has been a very lovely discussion too. So many thanks again for being here.
Obrigado.
Okay, thank you. Thank you very much.